Hello everyone. Today we are going to find the shape factor for a triangular section. Let us consider a triangle having the height h and breadth b. We know the formula for the shape factor. S is equal to Zp by Z. In this formula, Zp is the plastic modulus, Z is the elastic modulus. First, let us calculate elastic modulus. The formula is I by Y. We know that for a triangle, the moment of inertia formula is BH cubed by 36. This triangle is not symmetrical. In this triangle, the centroid lies at a distance of 2h by 3 from the apex and at a distance of h by 3 from the base. The neutral axis lies along the centroid. From the neutral axis, we are having two different values. One is 2h by 3 and another is h by 3. So here we may have some confusion which one we have to apply for y. For the value of y, we have to take the maximum value. Comparing both of these values, 2h by 3 is the maximum value. So y max is equal to 2h by 3. In the formula, we can apply the values of I and y. We can take 2h by 3 inversely and then multiply. We can cut this h and cube. Here it will be square. Also we can cut 3 and 36. Here it will be 12. 12 into 2 we will get a 24. Finally we are getting z is equal to bh square by 24. Now let us calculate the plastic modulus Zp. The formula is a by 2 into y1 bar plus y2 bar. We know the formula for the area of a triangle. A is equal to bh by 2. For calculating y1 bar and y2 bar, we have to split the triangle into two parts about the equal area axis. So the area will be separated into two parts on the top and bottom. So the total area will be split into two equal halves. In this triangle, let us keep the height as h1 and the breadth as b1. The total height is h. So here the height will be h minus h1. Here we have to calculate the values of h1, h minus h1 and b1. For that we are having two conditions. According to the properties of the triangle, b1 by b is equal to h1 by h. You can see that b1 by b is equal to h1 by h. From here we can derive one formula for h1. h1 is equal to b1h by b. Also we know that a1 is equal to a2 is equal to a by 2 because the total area is divided into two equal parts. We know that a1 is equal to a2 is equal to a by 2. Let us calculate a1. This is a triangle. The area formula is half into b1 into h1. So for a1 we are having b1 h1 by 2. We already know the total area. The total area by 2 is equal to 1 by 2 into bh by 2. Here we can cut this 2 and 2 and take the h1 on the right side. So it will go in the denominator. So b1 is equal to bh by 2h1. Previously we have already made a formula for h1 which is equal to b1h by b. In the formula, instead of b1, we can apply bh by 2h1. Then we can cut this b and b. Also take the h1 on the left side. h1 into h1 we will get h1 square. h into h we will get h square. To calculate h1, we have to take root of these values. We can take h square outside. It will become h. So h1 is equal to h by root 2. b1 by b is equal to h1 by h. From here we will calculate b1. We already calculated the value of h1. Instead of h1 we can apply h by root 2. We can eliminate this h and this h. Finally, we are getting b1 is equal to b by root 2. Now let us calculate h minus h1. The value of h1 is equal to h by root 2. Then we can take the h outside. 1 minus 1 by root 2, we will get 0.293. So h minus h1 is equal to 0.293h. Now we can easily calculate y1 bar and y2 bar. y1 bar and y2 bar should be calculated from the equal area axis. First, let us calculate y1 bar. In a triangle, the distance between the centroid to the apex is 2 by 3 into height, and the distance between the centroid to the base is 1 by 3 into height. We need the distance between the centroid to the base, that is y1 bar. Here the height is h by root 2, so y1 bar is equal to 1 by 3 into h by root 2. After calculations, we are getting y1 bar is equal to 0.236h. We have calculated y1 bar. Now let us calculate y2 bar. This is a trapezoid. Let us consider a trapezoid having the dimensions of A on the top and B on the bottom. The distance from the centroid to the top is A plus 2B by A plus B into h by 3. In this formula, we can apply the values. Here A is equal to B by root 2, B is equal to B, h is equal to 0.293h. We can apply all of the values. Here 1 by root 2 is equal to 0.7071b. Then we can add these two values and these two values. After adding, we are getting this. Then we can cut this b and this b. After the calculations, we are getting y2 bar is equal to 0.155h. Now let us calculate the plastic modulus ZP. We already know the area value and we have calculated y1 bar and y2 bar. Here we are having A by 2, so the area BH by 2 into 1 by 2. H into H, we will get H square. For ZP, we are having this value 0.09775 BH square. Now let us calculate the shape factor. We have already calculated ZP and Z. We can apply both of the values. After multiplying these two values, we are getting S is equal to 2.346. We can eliminate BH square and BH square. After multiplying these two values, we get S is equal to 2.346. Now let us find the shape factor for the another type of triangle. In this triangle, the height is given as h and the breadth is given as b. In this triangle, we can easily calculate the shape factor because it is symmetrical on the top and bottom. So the neutral axis lies on the center. We know that the formula for shape factor is equal to Zp by Z. In this formula, first let us find Z, the elastic modulus. The formula is I by Y. Here we are having two triangles, the first one and the second one. For one triangle, the moment of inertia formula is BH cube by 12. Here the height is h by 2, so we have to apply h by 2. Since we are having two triangles, we are multiplying by 2. In this case, we are applying different formula for the moment of inertia. In a triangle, the moment of inertia about the neutral axis is equal to BH cube by 36. The moment of inertia about the base is equal to BH cube by 12. In our case, we are calculating the moment of inertia about the base of these two triangles. So we have to follow this formula bh cube by 12. Here instead of h we are having h by 2. That is why we are applying h by 2 in the formula. Also we are having two triangles. That is why we are multiplying with 2. Here 2 cube we will get 8. Then we can cut this 2 and 12. Here it will be 6. 6 8s are 48. So the moment of inertia I is equal to bh cube by 48. Now let us find y. The neutral axis lies on the center. On both of the sides of the neutral axis we are having h by 2. So y is equal to h by 2. In the elastic modulus formula we can apply the values of I and y. Finally we are getting z is equal to bh square by 24. Now let us calculate the plastic modulus Zp. The formula is a by 2 into y1 bar plus y2 bar. We know the formula for the area of a triangle. A is equal to breadth into height by 2. For calculating y1 bar and y2 bar, we have to split the triangle into two parts about the equal area axis. This triangle is symmetrical. The equal area axis lies on the center. About the equal area axis, we have to split the triangle into two parts. So for calculating y1 bar and y2 bar, we have split this triangle into two triangles. In the first triangle, let us calculate y1 bar. Y1 bar is the distance between the centroid to the base. The distance between the centroid to the base in a triangle is 1 by 3 into height. Here for the height we are having h by 2. So y1 bar is equal to 1 by 3 into h by 2. Here you can see that both of these triangles are having the same shape. So y1 bar will be equal to y2 bar, which is equal to h by 6. Now let us calculate Zp. In this formula, we know the area value, y1 bar value and y2 bar value. We can apply all of them. H by 6 plus h by 6, we will get 2h by 6. 2 into 2, we will get 4. We can cut this 2 and 4. Here it will be 2. 2 into 6, we will get 12. H into h, we will get h square. Finally, Zp is equal to bh square by 12. In the shape factor formula, we have found Zp and Z. We can apply both of the values. We can take bh square by 24 inversely and then multiply. We can eliminate bh square and bh square. Then 24 by 12, we will get 2. Finally, we have found the shape factor, which is equal to 2. Now, we are going to end this session. Thank you for watching this video.